Hello everyone, welcome to my channel. Let's learn some concepts on quadratic equations. Standard form of quadratic equations, methods of solving quadratic equations, relationship between discriminant and natural roots, word problems based on quadratic equations. An equation of the form ax² plus bx plus c equal to 0 is called the standard form of a quadratic equation, where a, b, c are real numbers with a not equal to 0. Now, let's discuss methods of solving quadratic equations. First, factorization method. Second, quadratic formula method. Third, completing the square method. First, factorization method. Step 1. First, keep in mind the middle term. For example, 2x square minus 6x minus 8 equal to 0. Middle term is minus 6x. Step 2. Split the middle term into two terms such that their sum is equal to the middle term itself and their product is equal to the product of the first term and the constant term. For example, in the quadratic equation 2x square minus 6x minus 8 equal to 0, split the middle term minus 6x into two terms minus 8x and 2x, such that their sum, that is minus 8x plus 2x, equal to minus 6x, which is the middle term itself, and their product minus 8x into 2x, that equal to minus 16x square, which is equal to the product of first term and constant term, that is 2x square minus 8 is equal to minus 16x square. Step 3. Arranging four terms so formed properly into two groups, each with two terms. Factorize to form two factors. For example, in the above equation, after splitting the middle term, we have 2x square minus 8x plus 2x minus 8 equal 0. Then grouping into two groups, we have 2x square minus 8x plus 2x minus 8 equal to 0. Then taking common, 2x whole into x minus 4 plus 2 into x minus 4 equal to 0. So here, taking x minus 4 common, we have x minus 4 whole into 2x plus 2 equal to 0. So here two factors, x minus 4 and 2x plus 2. Step 4. Equating each factor to 0, that is zero product rule, find the roots of the equation, that is the values of x. So here x minus 4 whole into 2x plus 2 equal to 0. That implies that x minus 4 equal to 0 and 2x plus 2 equal to 0. That implies that x equal to 4 and 2x equal to minus 2. That implies that x equal to minus 1. So we get two values of x. Let's solve some questions based on this method. Example 1. Find the roots, that is the values of x, of the following quadratic equations by the factorization method. First part, 2x square plus x minus 6 equal to 0. Second part, root 2x square plus 7x plus 5 root 2 equal to 0. Third part, 21x square minus 2x plus 1 upon 21 equal to 0. Now let's solve the question. First part, 2x square plus x minus 6 equal to 0. Now split the middle term plus x into two parts, that is 4x and minus 3x, such that the sum of these two terms, that is 4x minus 3x, that equal to x, that is the middle term itself, and 4x into minus 3x, that equal to minus 12x square. Now that implies that 2x square plus 4x minus 3x minus 6 equal to 0. That implies that 2x common, x plus 2 minus 3 common, x plus 2 equal to 0. Now taking x plus 2 common, we get x plus 2 whole into 2x minus 3 equal to 0. That implies that either x plus 2 equal to 0 or 2x minus 3 equal to 0. That implies that x equal to minus 2, that is one value of x, and 2x minus 3 equal to 0. That implies that x equal to 3 upon 2, that is the other value of x. Second part, root 2 x square plus 7x plus 5 root 2 equal to 0. Now similarly split the middle term 7x into two terms 5x and 2x such that their sum means 5x plus 2x equal to 7x, the middle term itself, and 5x into 2x, the 10x square, that is the product between first term and constant term. That implies that root 2x square plus 5x plus 2x plus 5 root 2 equal to 0. Now taking x common, root 2x plus 5 plus taking root 2 common, root 2x plus 5 equal to 0. Now root 2x plus 5 taking common, we get root 2x plus 5 whole into x plus root 2 equal to 0. So either root 2x plus 5 equal to 0 or x plus root 2 equal to 0. That implies that root 2x plus 5 equal to 0. That implies that x equal to minus 5 upon root 2, that is the one value of x. Then other x plus root 2 equal to 0. That implies that x equal to minus root 2, the other value of x. Third part, 21x square minus 2x plus 1 upon 21 equal to 0. That implies that 441x square minus 42x plus 1 upon 21 equal to 0. That implies that 441x square minus 42x plus 1 equal to 0. Now split the middle term minus 42x as two terms, minus 21x and minus 21x. Now we get 441x square minus 21x minus 21x plus 1 equal to 0. That implies that 21x common whole into 21x minus 1 and minus 1 common, 21x minus 1 equal to 0. Taking common 21x minus 1 whole into 21x minus 1 equal to 0. That implies that 21x minus 1 equal to 0 or 21x minus 1 equal to 0. That implies that x equal to 1 upon 21 and same x equal to 1 upon 21. That's your answer. Example 2. If one of the roots of the equation px square plus 15x minus 14 equal to 0 is 2 by 3, find the value of p and the value of the other root. Let us solve this question. Given px square plus 15x minus 14 equal to 0. Putting one value of x equal to 2 by 3 in this equation, we get p whole into 2 by 3 whole square plus 15 into 2 by 3 minus 14 equal to 0. That implies that p whole into 4 by 9 plus 10 minus 14 equal to 0. On simplifying, we get 4p by 9 equal to 4. That implies that p equal to 9 into 4 upon 4. That implies that p equal to 9. That's the answer for the first part, for the value of p equal to 9. For the second part, we have px square plus 15x minus 14 equal to 0. Putting the value of p equal to 9 in this equation, we get 9x square plus 15x minus 14 equal to 0. Split the middle term plus 15x into two terms, 21x and minus 6x, such that their sum equal to 15x, which is the middle term itself, and their product is equal to minus 126x square. That implies that 9x square plus 21x minus 6x minus 14 equal to 0. That implies that 3x whole into 3x plus 7 minus 2 whole into 3x plus 7 equal to 0. Now taking 3x plus 7 as common, we have 3x plus 7 whole into 3x minus 2 equal to 0. That implies that 3x plus 7 equal to 0 or 3x minus 2 equal to 0. That implies that x equal to minus 7 upon 3 or x equal to 2 by 3. Hence, x equal to minus 7 upon 3 is the other root of the equation. Now, let's discuss solving quadratic equations using quadratic formula. A quadratic equation in standard form is given by ax² plus bx plus c equal to 0, where a, b, c are real numbers and a not equal to 0. The quantity b square minus 4ac is designated as the discriminant d. That is d equal to b square minus 4ac. If d is greater than or equal to 0, then the roots, that is the values of x of the quadratic equation, can be found out using the quadratic formula, that is x equal to minus b plus minus square root of d upon 2a, that equal to minus b plus minus square root of b square minus 4ac upon 2a, that is alpha means one value of x equal to minus b plus square root of b square minus 4ac upon 2a, and beta, the other value of x, equal to minus b minus square root of b square minus 4ac upon 2a. Thus, these are the two values of x. Now, let's solve some questions based on this quadratic formula. Example 1. Solve the following quadratic equations using the quadratic formula. First, 2x square minus 7x plus 3 equal to 0. Second, x square minus 2 whole into x square plus b square x plus whole square of x square minus b square equal to 0. Now, let's solve this question. Given 2x square minus 7x plus 3 equal to 0. Comparing this equation with Ax² plus Bx plus C equal to 0, we have A equal to 2, B equal to minus 7, C equal to 3. Now, using the quadratic formula, we have x equal to minus b plus minus whole square root of b square minus 4ac upon 2a, that equal to minus into minus 7 plus minus whole square of minus 7 minus 4 into a means 2 into c means 3 upon 2 into 2, because a equal to 2. That's equal to minus into minus plus, the plus 7 plus minus 7 square 49 minus 24 whole square root divided by 4, that equal to 7 plus minus square root of 25 upon 4. Now 7 plus minus square root of 25 equal to 5 by 4, that equal to 7 plus 5 upon 4 or 7 minus 5 upon 4, that equal to 12 upon 4 or 2 upon 4, that equal to 3 half. These are the values of x. Second part, we have x square minus 2 whole into a square plus b square x plus whole square of a square minus b square equal to 0. Now, comparing it with the standard form of the equation, we get a equal to 1, b equal to minus 2 whole into a square plus b square and c equal to a square minus b square whole square. Now, discriminant d equal to b square minus 4ac, that equal to whole square of minus 2 into a square plus b square minus 4 into 1 into a square minus b square whole square. So, simplifying, we get 4 whole into a to the power 4 plus b to the power 4 plus 2a square b square minus 4 whole into a to the power 4 plus b to the power 4 minus 2a square b square, that equal to 4 a to the power 4 plus 4 b to the power 4 plus 8 a square b square minus 4 a to the power 4 minus 4 b to the power 4 plus 8 a square b square. Just cancelled, 4 a to the power 4 minus 4 a to the power 4b4 minus 4b4. So, we get 16 a square b square. That implies that square root of d equal to square root of 16 a square b square, that equal to 4ab. So, now we get square root of d equal to 4ab. Now, using the quadratic formula, we have one value of x equal to minus b plus square root of d upon 2a, that equal to 2a square plus b square plus 4ab, because square root d equal to 4ab. Opening brackets, we get 2a square plus 2b square plus 4ab upon 2, that equal to a square plus b square plus 2ab. It is the formula of a plus b whole square. So this is the one value of x. Now the other value of x. Equal to minus b minus square root of d upon 2a, that equal to 2 whole into a square plus b square minus 4ab upon 2. Opening brackets, we get 2a square plus 2b square minus 4ab upon 2, that equal to a square plus b square minus 2ab. This is the formula of whole square of a minus b. This is the other value of x. Hence, these are the two values of x. Now, let's consider example 2. Solve for x. 1 upon 2a plus b plus 2x equal to 1 upon 2a plus 1 upon b plus 1 upon 2x, where x is not equal to 0, x is not equal to minus 2a minus b upon 2, ab not equal to 0. Now, let's solve this question. We have 1 upon 2a plus b plus 2x minus 1 upon 2x equal to 1 upon 2a plus 1 upon b. On simplifying, we get 2x minus 2a minus b minus 2x upon 2x whole into 2a plus b plus 2x, that equal to b plus 2a by 2ab. Cross multiplying and simplifying, we get 2a plus b whole into 4ax plus 2bx plus 4x square equal to minus 2ab whole into 2a plus b. Cancel both sides, 2a plus b. We get 4x square plus 4ax plus 2bx plus 2ab equal to 0. That implies that 2x square plus 2ax plus bx plus ab equal to 0. Now, on simplifying, we get 2x square plus x whole into 2a plus b plus ab equal to 0. Comparing it with the standard form of the equation, we get a equal to 2, b equal to 2a plus b and c equal to ab. Now, using the quadratic formula, we have x equal to minus b plus minus square root of b square minus 4ac upon 2a, that equal to minus 2a minus b plus minus whole square of 2a plus b plus 4 into 2 into C AB upon 2 into 2 because a equal to 2. On simplifying, we get minus 2a minus b plus minus, just use the formula a plus b whole square, 4a square plus b square plus 4ab minus 8ab square root upon 4. Further simplifying, we get minus 2a minus b plus minus square root of 4a square plus b square minus 4ab upon 4. That equal to minus 2a minus b plus minus 2a minus b whole square square root upon 4. That equal to minus 2a minus b plus minus 2a minus b upon 4. That implies that x equal to minus 2a minus b plus 2a minus b upon 4, or x equal to minus 2a minus b minus 2a plus b upon 4. That implies that x equal to 2a minus 2a cancelled, so we get minus 2b upon 4, or b minus b cancelled, minus 4a upon 4. That implies that x equal to minus b upon 2, or x equal to minus a. Hence, the values of x equal to minus b upon 2 minus a. That's the answer. Let's know how to solve quadratic equations by computing the squares. Now, let's solve some quadratic equations by this method. Example 1. Solve the following quadratic equation by the method of computing the square. X square minus 8x plus 12 equal to 0. Now, let's solve this question. Given x square minus 8x plus 12 equal to 0 implies that x square minus 8x equal to minus 12. That implies that x square minus 8x plus 16 equal to minus 12 plus 16. Just we have added 16 on both sides. That implies that x square minus 2 into 4x plus 4 square equal to 4. That implies that, so this is just a minus b whole square, means x minus 4 whole square equal to whole square of plus minus 2. Now, taking square root of both sides, we have the square root of whole square of x minus 4 equal to the square root of whole square of plus minus 2. That implies that x minus 4 equal to plus minus 2. That implies that x equal to 2 plus 4, or x equal to minus 2 plus 4. That implies that x equal to 6, or x equal to 2. Thus, 2, 6 are the values of x. That's the answer. Example 2. find the roots of the equation 5x square minus 6x minus 2 equal to 0 by the method of completing the square. Now let's solve this question. Given 5x square minus 6x minus multiplying both sides of this equation by 5, we get 5 whole into 5x square minus 6x minus 2, that equal to 5 into 0. Opening the brackets, we get 25x square minus 30x minus 10 equal to 0. That implies that 25x square minus 30x plus 9 minus 9 minus 10 equal to 0. Just we add and subtract 9 in the left hand side of this equation. On simplifying further, we get whole square of 5x minus 2 into 5x into 3 plus 3 square minus 3 square minus 10 equal to 0. Just look at this expression. This is equal to whole square of 5x minus 3 minus 9 minus 10 equal to 0. That implies that 5x minus 3 whole square equal to 19. Now taking the square root of both sides, we get the square root of whole square of 5x minus 3 equal to square root of 19. That implies that 5x minus 3 equal to plus minus square root 19. That implies that 5x equal to 3 plus minus square root of 19. That implies that x equal to 3 plus square root of 19 upon 5, 3 minus square root of 19 upon 5. Hence, we obtain these two values of x. That's the answer. Now, let's discuss the relationship between discriminant and natural roots of a quadratic equation. In a quadratic equation, x square plus bx plus c equal to 0, the discriminant d equal to b square minus 4ac. Generally, there are four relations between discriminant and natural roots of a quadratic equation. If d is greater than 0, both the roots are real and distinct. If d equal to 0, both the roots are real and equal. If d is less than 0, there are no real roots, that is imaginary roots. If d is the perfect square, both the roots are rational and distinct. Let's solve some questions based on this concept. Example 1. Without solving, find the natural roots of the equation x plus 1 whole into x minus 2 plus x equal to 0. Let's solve this question. We have x plus 1 whole into x minus 2 plus x equal to 0. Now, opening the brackets, we get x square minus 2x plus x minus 2 plus x equal to 0. That implies that x square minus 2x plus 2x minus 2 equal to 0. 2x minus 2x get cancelled. That implies that x square minus 2 equal to 0. Comparing it with the standard form of the equation, we have a equal to 1, b equal to 0 and c equal to minus 2. Now, the discriminant d is given by b square minus 4ac, that equal to 0 square because b equal to 0 minus 4 into 1 into minus 2, that equal to 8. Since 8 is greater than 0, the given equation has two distinct real roots. Example 2. Find the value of k if the quadratic equation x square minus 3kx plus 9 equal to 0 has no real roots. Let's solve this question. Given x square minus 3kx plus 9 equal to 0. Comparing it with standard equation, we get a equal to 1, b equal to minus 3k and c equal to 9. Now, discriminant d equal to b square minus 4ac, that equal to minus 3k whole square minus 4 into 1 into 9, that's equal to 9k square minus 36, that equal to 9 whole into k square minus 4. Since the equation has no real roots, we have d is less than 0. That implies that 9 whole into k square minus 4 is less than 0. That implies that k square minus 4 is less than 0. That implies that k square is less than 4. That implies that k square is less than whole square of plus minus 2. Now taking the square root of both sides, we have square root of k square is less than the square root of whole square of plus minus 2. That implies that k is less than minus 2 or k is less than plus 2. That implies that minus 2 is less than k is less than 2. These are the values of k, which is your required answer. Example 3. Find the value of k such that the quadratic equation k minus 4 whole into x square plus 2 k minus 4 into x plus 4 equal to 0 has equal roots. Let's solve this question. Given k minus 4 whole into x square plus 2 k minus 4 whole into x plus 4 equal to 0. Comparing it with the standard form of the equation, we get a equal to k minus 4, b equal to 2 into k minus 4 and c equal to 4. Now, discriminant d equal to b square minus 4ac, that equal to whole square of 2 whole into k minus 4 minus 4 whole into k minus 4 into 4. That implies that d equal to 4 whole square of k minus 4 minus 16 whole into k minus 4, that equal to 4 whole into k minus 4 into k minus 4 minus 4. That implies that d equal to 4 whole into k minus 4 whole into k minus 8. Since the equation has equal roots, d equal to 0. That implies that 4 whole into k minus 4 whole into k minus 8 equal to 0. That implies that k minus 4 equal to 0 or k minus 8 equal to 0. That implies that k equal to 4 and 8. Let's examine these two values of k. If k equal to 4, then a equal to k minus 4 that equal to 4 minus 4 that equal to 0. But a can't be equal to 0. So reject the value of k equal to 4. So we get the value of k equal to 8, which is your required answer. Example 4. Determine whether the quadratic equation x square minus 4x minus 5 equal to 0 has both the roots rational and distinct. Let's solve this question. Given that x square minus 4x minus 5 equal to 0. Now the discriminant d equal to b square minus 4ac, that equal to minus 4 whole square, because b equal to minus 4 into 1 into minus 5, because c equal to minus 5, that equal to 16 plus 20, that equal to 36. Since d equal to 36 is a perfect square, because 6 square equal to 36. So the roots of this quadratic equation are rational and distinct. That's your answer. Now let's discuss word problems based on quadratic equations. We come across various daily life activities which can be framed in the form of quadratic equations. On solving the quadratic equations, we can find the unknown values in the word problems. Steps of framing and solving quadratic equations in word problems. Step 1. Read the word problems carefully and keep in mind what are given and what is or are to be found out. Step 2. Consider the unknown quantity to be found out as a variable x. We can assume any other alphabet as a variable. Step 3. Frame or form quadratic equation as per the given statements in the word problems. Step 4. Solve the framed quadratic equation to find the value of x. Let's solve some word problems based on quadratic equations. Example 1. By increasing the speed of a car by 10 km per hour, the time of journey for a distance of 72 km is reduced by 36 minutes. Find the original speed of the car. Let's solve this word problem using the following steps. Step 1. Keep in mind what are given, such as first, a distance of 72 km. Second, original speed is increased by 10 km per hour. Third, time of traveling is reduced by 36 minutes. Also, identify that which is to be found out, that is, original speed of the car. Step 2. Consider the unknown quantity to be found out as a variable x. Let x km per hour be the original speed of the car. Step 3. Frame the quadratic equation as per the given statements. such as original time of journey is given by the expression 72 km upon x km per hour equal to 72 upon x hour. Then revised time of journey becomes 72 km upon x plus 10 km per hour, because the speed is increased by 10 km per hour, that equal to 72 upon x plus 10 hour. On increasing the speed of the car by 10 km per hour, the time of journey for the distance of 72 km is reduced by 36 minutes. That is 72 upon x minus 72 upon x plus 10 equal to 36 upon 60, because 36 minutes equal to 36 upon 60 hour. That implies that two upon x minus 2 upon x plus 10 equal to 1 upon 60. On simplifying, we get 2x plus 20 minus 2x upon x whole into x plus 10 equal to 1 upon 60. Cross multiplying and simplifying, we get x square plus 10x minus 1200 equal to 0. That's the quadratic equation framed now. Step 4. Solve the framed equation so formed by any method convenient to you to find the unknown value, that is the value of x. Here, using the factorization method, we solve the equation. The framed equation is x square plus 10x minus 1200 equal to 0. That implies that x square plus 40x minus 10x minus 1200 equal to 0. That implies that x taking common, then x into x plus 40 minus 30 taking common, then 30 into x plus 40 equal to 0. That implies that x plus 40 taking as common, so x plus 40 whole into x minus 30 equal to 0. That implies that x plus 40 equal to 0 or x minus 30 equal to 0. That implies that x equal to minus 40 or x equal to 30. Since the speed can't be negative, so minus 40 neglected. So x equal to 30. Hence, the original speed of the car is 30 km per hour. That's your answer. Example 2. A train travels a distance of 480 km at a uniform speed. If the speed had been 8 km per hour less, then it would have taken 3 hours more to cover the same distance. Find the usual speed of the train. Let's solve this question. Let the original speed of the train be x km per hour. When the speed of the train is decreased by 8 km per hour, then its new speed becomes x minus 8 km per hour. Total distance covered equal to 480 km. Now, time taken by the train to cover 480 km with the usual speed of x km per hour equal to 480 upon x, because we know that time equal to distance upon speed. Then the time taken by the train to cover 480 km with the new speed x minus 8 km per hour equal to 480 upon x minus 8 hour. Since the train has taken 3 hours more to travel the same distance, we have 480 upon x minus 8 minus 480 upon x equal to 3. That implies that 480x minus 480 whole into x minus 8 upon x into x minus 8 equal to 3. Now cross multiplying and simplifying, we get 480x minus 480x plus 3840, that equal to 3 whole into x square minus 8x. Simplifying further, we get 3x square minus 24x minus 3840 equal to 0. That implies that x square minus 8x minus 1280 equal to 0. This is the quadratic equation framed now. Comparing it with the standard form of the equation, we have a equal to 1, b equal to minus 8 and c equal to minus 1280. Now using the quadratic formula, we have x equal to minus b plus minus square root of b square minus 4ac upon 2a, that equal to minus into minus 8 plus minus minus 8 square minus 4 into 1 into minus 1280 square root divided by 2 into 1, that equal to minus minus plus 8 plus minus whole square root of 64 plus 5120 upon 2. That implies that x equal to 8 plus minus 5184 square root by 2, that equal to 8 plus minus 72 upon 2, because square root of 5184 equal to 72, that equal to 8 plus 72 upon 2 or 8 minus 72 upon 2, that equal to 80 upon 2 or minus 64 upon 2, that is 40. So that equal to 40 or minus 32. Since the speed cannot be negative, so minus 32 is neglected. That implies that x equal to 40. So x equal to 40 km per hour is the usual speed of the train. That's your answer. I think this video would be very useful for you. If you have any queries, please comment in my comment box. Please like and share this video. Also subscribe my channel and hence press the bell icon to get the latest notifications of my videos. Thanks.